Bilharzia affects more than 200 million people worldwide, especially young children in Africa. It is caused by parasitic worms that are spread by freshwater snails. Chronic infection leads to serious damage of intestinal organs, growth retardation, school dropout, and infertility.
Freshwater snails are such an important element in the cycle of infection of the disease, meaning that without snails, there is no disease. Nevertheless, there is a major knowledge gap about the distribution and dynamics of the vector. So, having detailed information about these tiny snails requires numerous and intensive sampling campaigns, which are a major challenge in rural areas with limited access to resources and snail experts. So, a solution for this, a cost-effective solution, is citizen science. Citizen science is an approach where members of the community are involved in scientific activities, usually looking for the benefit of their own community. Following this reasoning, we ideated the ATRAP project, Action Towards Reducing Aquatic Snail-borne Parasitic Diseases, which since 2019 implemented a groundbreaking citizen science approach to monitor snail vectors of snail-borne diseases in Uganda and Congo. Each country comes with 25 citizen scientists that weekly monitor snail populations and water-related activities in 76 fixed locations. This is how the snail sampling is done. The citizens are equipped with protective gear, a snail scoop, a smartphone, and a snail ID key. Once the citizens finish with the scooping, they place the snails in a graph paper and take a picture which then will be uploaded to a cloud for further analysis.
The current data gives us information on potential transmission sites. This is why in our next phase we will integrate a rapid diagnostic LAMP technique to directly detect eDNA or environmental DNA from the parasite in water. And the beauty of LAMP technique is it's adaptable to field conditions, which is ideal for low resource settings, therefore identifying actual transmission sites in real time.
This citizen science generated data will be used to develop advanced distribution models that predict the presence of snails and parasites based on environmental conditions obtained from novel remote sensing products, as Sentinel. And this makes possible to extend the area of interest in the present. We also plan to generate predictions for the future using state-of-the-art Cosmos CLM simulations. And this is because we are concerned about the increased frequency of extreme events and the sustained change of temperatures that could eventually extend the area of distribution of the parasite and also the snail, and as a consequence, skyrocket the exposure of rural communities to NTDs. At the moment, we analyzed more than 6,000 reports, and we found less than 1% of mistakes in identification of snails. This is due to the feedback between the ATRAP team and the citizens. The feedback can be provided through online platforms as well as in person, with the organization of refresher trainings with an expert on the field. But we did not stop there. We were also concerned about how well the citizens could detect snails in a certain place in comparison with an expert. We call this observation bias. And we found that the trends are highly similar to expert collected data. But citizen science is much more than data collection, because while the citizens learn about snail sampling, they also learn about the disease, increasing the awareness of the community regarding snail-borne diseases.
In a nutshell, the ATRAP citizen science model has proven its ability to transform communities and yield resourceful open access scientific data. And the best part is that the citizen science approach can be upscaled and implemented in NTD endemic regions, such as in Chad, where a similar initiative is being set up based on the ATRAP example.
Bye.